Okay, this is going to be chapter 16, section 1 lecture. The summary here is that heat flows spontaneously from a hotter object to a cooler object, and it doesn't go the other way. A reversible process or an equilibrium process is a process whose direction can be reversed by an infinitesimal change in the conditions of the process. So if we go to the section here to discuss things a little bit more, a reversible process is something that a system can undergo if the system remains in thermodynamic equilibrium within itself and with its surroundings during the process. So in a reversible process, any change of state that takes place can be reversed or made to go the other way by making appropriate changes to the conditions of the system. Although there are no truly reversible thermodynamic processes in nature, you can approximate this by simply making infinitesimal changes to the conditions of the system. So, for example, heat flow between two objects generally is not reversible, but if the two objects' respective temperatures differ just in a small manner, then the heat flow can be reversed by making only a very small change in one temperature or the other. And likewise, a gas that is allowed to expand slowly and adiabatically by a small amount can be brought back to its original state by compressing it. So with reversible processes, what you're looking at is that you see that Newton's laws can operate forwards and backwards. There's not really a direction in a reversible process. In other words, they can go one way or the other, and you really can't tell the difference. They should apply in both cases. Reversible processes are thus equilibrium processes. Now, by contrast, heat flow with a finite temperature difference or free expansion of a gas and conversion of work to heat are going to be irreversible processes. No small change in conditions can make any of them go the other way. In other words, once you lose work to heat by friction, there's really no way to get that back. And because of that, we consider that to be irreversible. So, and reversible processes are, in fact, an idealization that can never be precisely attained in the real world. Now, we can get close, but we can't exactly reproduce a reversible process. What we're also going to be doing is we're going to be talking about irreversible processes and their direction through the concept of entropy. Sometimes it's referred to as disorder, but that's not really the best way to categorize this. What you are looking for is an increase in the number of states possible for particular micro components of your system. What we're going to refer to that later on is entropy. That is going to come a little bit later here. So later on here, we're going to discuss the second law of thermodynamics, which is going to discuss entropy through heat engines, where you convert heat into work, and refrigerators, which are partly successful in transporting heat from cooler objects to hotter objects.